This is my beginning algebra course. Today we're going to learn polynomials. Polynomial is just a fancy term for the expression that you see down here. We're going to begin by simplifying polynomials, and we're also going to write the polynomials in descending order of powers. And lastly, we're going to state the degree of each polynomial. So three things that we have to do for these problems. Now, we learned in the last class that we cannot add unlike terms. We have these seventh power terms, and we have fifth power terms, and we have a first power term, and we have what's called the zero power term. So we cannot combine the different colors. We have to combine just the yellows and together and just the blues and so on and so forth. So first we'll combine the yellows. 8x to the 7th power plus 3x to the 7th power is 11x to the 7th power. So what you can do is you can lightly cross these out. Actually, I'm just going to use the highlighter. And negative 2x to the 5th power minus 9x to the 5th power is negative 11x to the 5th power. And so we're done with those. Again, you can lightly cross them out with your pencil or digital pen. And these two terms are unlike terms, so we cannot combine those. So we just write plus 6x and plus 4. So we did two things. We simplified the polynomial, and I can go ahead and mark those out because we're done with those. So we simplified the polynomial by combining like terms, and we wrote the polynomial in descending order of powers because we have 7th power, 5th power, 1 power, 0 power. So descending means starting with the biggest number and going to the smallest number in terms of the powers. So now we just have to write the degree of the polynomial. So the degree is very easy. That's just the highest power of the variables. So the highest power is 7. So we write d is equal to 7 and make sure to put a comma there. So this is one answer here, and this is the other answer. So as you can see, the class today is going to be pretty easy, but we're going to do some things that are a little bit more difficult. But this class is really not going to be too bad. Polynomials are going to be fairly simple, at least in this class. So now let's do another problem. So let's look for the highest powers, and that is the fourth powers. So 3x to the 4th power plus 8x to the 4th power is 11x to the 4th power. That's just a coincidence. We keep getting 11x's. So I'm going to go ahead and cross those out. It really helps to cross out the ones that you've already combined. And then I'm going to combine these three terms because they all have x to the 2nd power. Negative 5 plus 3 is negative 2, and negative 2 plus negative 4 is negative 6, x to the 2nd power. And cross those out. And we're going to combine 6x and negative 2x and 5x, and then we get 9x. Cross those out. And let's see, 10 minus 9 is 1, and there you go. So we wrote the polynomial, or we simplified it and wrote it in descending order, and now we're going to write the degree. And what is the degree? You tell me. Well, the degree is the highest power, so if you said 4, you were correct. So again, these problems are fairly easy. And I should probably cross these out here. All right, so if you'd like to try one, go ahead and attempt this problem, and when you're done, we'll do it together. All right, we're back. So we're going to add negative x cubed. Actually, we can't add negative x cubed with anything because it's the only term, so we're just going to cross that one out. And let's see, now we can combine the x squared terms. So negative 12 plus 3 is negative 9. Negative 9 plus 1 is negative 8. And we can cross those out. And 6x minus 8x is negative 2x. We can cross those out. And we get 3. So there we go. That's the simplified polynomial. And the degree is the highest power, which is 3, so that would be 3. So if you got that answer, good job. All right, try the next one, and when you come back, we'll do it together. All right, we're back. So you should have 5x to the 4th and negative 4x squared and 5x and 1, it looks like. So I'm going to go ahead and cross out the ones that I combined. I'm sorry to take up the time doing this, but it really helps me also to make sure that I did it correctly, to cross out the ones that I already did. Because it's so easy to make a mistake in algebra. You know that from the last class. All right, try number, so if you got that answer, oh, whoops, I forgot to put the degree. I'm sorry about that. That would be 4. So if you got those answers, good job. All right, try number 5, and when you come back, we'll do it together. All right, we're back. So we're going to combine the 8 power terms. And we're going to combine the 5th power term, but there's really nothing to combine with that one. And negative 20x plus 2x is negative 18x. Negative 18x plus x is negative 17x. So you cross those out. So if you got that answer, good job. And the degree is the highest power, which is 8. Highest power is 8. So again, if you got those answers, good job. All right, we're just going to do one more of these problems, and we're going to go on to adding polynomials. We're just simplifying polynomials now, but in the next problems, we're going to add polynomials. And then we're going to subtract polynomials, and then we're going to multiply polynomials, and we're going to divide polynomials. But it's going to be pretty easy, so we're going to be done pretty quickly in this this class today. So go ahead and attempt this problem, and when you come back, we'll do it together. All right, we're back. So you should have 16x squared, because that's the highest power, and then you should have minus 7x. And you should have minus 2, and that is the simplified polynomial, and the degree is 2. So if you got those answers, good job. All right, so now we're going to add polynomials. Now let's take a look at this expression. You can see we have parentheses here. Now I want you to be aware that these parentheses are really unnecessary because there are addition signs between these two terms. When you have addition signs between two terms with parentheses, that means the parentheses are really unnecessary. So you're probably thinking, okay, well, why did we write the parentheses if they're unnecessary? Well, that's just to show you that we're adding one polynomial with another polynomial. It's to show you where one polynomial ends and the other starts. So what we can do is we can actually just get rid of those parentheses. We don't really need to do this intermediate step to get rid of the parentheses. We can just go ahead and add everything up. But I just want you to see very clearly here that the expression above is equal to the expression below without parentheses. So now we can go and add those up. So it's just the same problem that we did previously. We're just going to add like terms. So you can see that we have the biggest power there, and then we have x squared, and 6x plus 6x is 12x. And negative 8 minus 4 is negative 12. So there you go. And we could write the degree, but I'm not really going to make you do that in every problem because that's going to get kind of tedious to have to keep writing that over and over again. All right, so let's try another one. Again, I just want to demonstrate that you can just get rid of those parentheses. But at this point, I'm just gonna skip that step because you really don't have to get rid of the parentheses. You can go ahead and just add the like terms. So x cubed plus 4x cubed is 5x cubed. So I got rid of these terms. And negative 2x squared, that can't be combined with anything. And 3 plus negative 5 is negative 2. So there you go. So again, you can see that this is pretty easy. So why don't you try number 9? Again, you can just skip that intermediate step. You don't have to get rid of the parentheses. You can just consider them to be gone and add the like terms. So try number 9, and when you come back, we'll do it together. All right, we're back. So we gotta find the greatest power first, and you can see that there's nothing really to combine for the fifth power terms. So we'll just write that. Whoops. And then we'll combine the, well actually we'll just write the fourth power term. There's nothing to combine with that. 2x cubed minus 3x cubed is minus x cubed. And nothing to combine with the squared term. And then we have negative 6 plus negative 1, which is negative 7. Or you can think of that as negative 6 minus 1, and you get the same thing. All right, so if you got that answer, good job. Let me just double check that, make sure everything looks correct. Looks like everything's correct. On to the next problem. So try number 10, and when you come back, we'll do it together. All right, we're back. So here we have the greatest power, so we're going to just go ahead and write that. And then we have 6x and 5x, so we get 11x. And then 7 plus 7 is 14. And that should be the answer. Let me double check there. It looks like everything's correct. Right. So we got that answer. Good job. All right, on to number 11. Go ahead and try number 11, and when you come back, we'll do it together. All right, we're back. The highest power is the first term here, so that's negative x to the fourth. Then we have x cubed minus 2x cubed is negative x cubed. And let's see, we have x squared, nothing to combine it with. And let me go ahead and start marking some of these out so I don't confuse myself. Negative 3x plus 4x is x. And 7 plus 8 is 15. So if you got that answer, good job. And again, the degree is the highest power. You're going to have to know that for your homework. Try number 12. When you come back, we'll do it together. All right, we're back. The highest power is the second power, so negative 6 plus negative 4 is negative 10. And the next power is the first power, negative 2x plus x is, or negative 2x plus negative x is negative 3x. And negative 2 plus negative 3 is negative 5. So if you got that answer, good job. As you can see, this stuff is pretty easy. So we have one more of these problems, and then we're going to go on to subtracting polynomials. And that's going to be a little more tricky. So go ahead and attempt number 13, and when you come back, we'll do it together. All right, we're back. So the highest power is x squared, so x squared plus x squared is 2x squared. And we have 8x plus negative 4x is 4x. Negative 10 plus negative 9 is negative 19. Negative 19 plus 6 is negative 13. So if you got that answer, good job. Let me just double check that. Everything looks correct. So now we're going on to subtracting polynomials. Now this is different because we can't just get rid of the parentheses. What's happening here is we're subtracting this entire polynomial. So in a way, you can consider this to be like a -1, and we would have to use the distribution rule, but we would distribute to all these terms. Remember, we learned the distribution rule in the previous course. But you don't really have to think about the distribution rule. All you have to know is that you're going to change this sign to a plus, and all of these terms you're going to switch the sign. So let me explain. Let's get rid of the parentheses on this polynomial. We'll start by doing that. We are going to need an intermediate step here in this problem. So now we're going to change this sign to a plus sign and get rid of the parentheses. But now all of these terms are going to switch signs. So this is a positive 6x cubed, so it's going to become a negative 6x cubed. This is a negative 7x squared, so it's going to become a positive 7x squared. And this is a positive 2x, so it's going to become a negative 2x. And this is a negative 10x, so it's going to become a positive 10, or excuse me, not 10x, it's just 10. So there we go. We got rid of the parentheses. And to be honest with you, we don't really need parentheses here. Instead of writing plus negative 6x cubed, we could just get rid of the parentheses and the plus sign and just write a negative. In fact, I'm going to just go ahead and do that. So I'm going to get rid of those parentheses, and we're going to move the whole thing over because we can use the condensed notation. Hopefully that doesn't confuse you to do that. Again, we have a positive 6x cubed. It becomes a negative 6x cubed. All right, so at this point, it just reduces to the problems that we just did. So all we do is just simplify, and that's it. That's subtracting polynomials. So you can see it's a little bit more difficult, but it's still pretty easy. So let's go ahead and combine these terms. The x cubed terms are the highest power. So that would be negative 2x cubed. And let's see here. Negative 9x squared plus 7x squared is negative 2x squared. Negative 2x plus negative 2x is negative 4x. And 3 plus 10 is 13. And there you go. All right, let's try another one of these together before you try one on your own. So we're going to get rid of the parentheses on the left polynomial, the first polynomial. And then we're going to change this sign to a plus sign. And then we're going to just change all of the signs on the terms in the other polynomial. Let me just double check that. Everything looks correct, so now we just combine the terms. So the highest power is the fourth power term. And add the cube terms. And when I say cube, I mean to the third power. That's just a different way of saying it. So let's erase those before I confuse myself. Or not erase them, but just cross them lightly out. Again, if you're using a pencil, you just want to cross them lightly out. For example, if you wanted to cross out the negative 7, you would just put a light cross like that, just to show that you already combined it, or you already wrote it. But please don't. A lot of students like to cross out by doing this. Well, now you can't see your work. You understand? So don't do that. Don't cross out completely, because now we don't know what we did. You have to go back and see what your work is for multiple reasons. Then we just rewrite the 2x squared term and the 3x term. And the negative 7 plus negative 2 is negative 9. And there we go. Again, I'm saying negative 7 plus negative 2, but I can also say negative 7 minus 2. It's the same thing. On to the next problem. So we'll try one more of these before you try one on your own. Actually, why don't you just go ahead and try this one on your own, and when you come back, we'll do it together. All right, we're back. So we're going to get rid of the parentheses in the first polynomial. Change to positive, change that to negative, and so on and so forth. So again, all we did was just change the signs in this polynomial because we're subtracting this whole polynomial. Actually, you know what? Yeah, that's correct. I almost confused myself there. Let me just double check that. Everything looks right. All right, so the biggest power is the fourth power. So we're going to write that first. And then add the cube powers. Looks like that's going to be x cubed. And cross those out. Add the squared terms, you can get negative 4x squared. And 3x plus 6x is 9x. And 5 plus 3 is 8. So if you got that polynomial, good job. All right, so try number 17, and when you come back, we'll do it together. All right, we're back. Now, this is the term that is somewhat different. We probably should have tried that one together. This is negative, so it becomes positive. Again, you switch all of these signs. All right, that looks correct, and we're going to combine the cube terms to get negative x cubed, and we get negative 5x plus 9. So if you got that answer, good job. All right, try number 18, and when you come back, we'll do it together. All right, we're back. Whoops, that should be a minus 2x to the fourth. And combine like terms. And remember, you always have to write, I didn't mention that, you always have to write in descending order of the powers. Well, I think you probably figured that out on your own, but I should mention that more clearly. This works when you're adding polynomials and subtracting them, not just simplifying that we did like we did in the first problems. Okay, so we're done with those terms, and now we have x squared and 7x. So there really wasn't a lot to combine in this problem. And we have negative 6. So if you got that answer, good job. All right, try number 19, and when you come back, we'll do it together. All right, we're back. Now we're ready to combine terms. The 8th power is the highest. Then we have the 5th power. And the 3rd power, also known as the cube term. There's just so many terms to keep track of. You really want to mark them out lightly so you don't confuse yourself. 4 plus 1 is 5. And there you go. If you got that answer, good job. All right, how many more of these do we have? I want to see what's going on here. Looks like we have 2 more of these problems. So try number 20, and when you come back, we'll do it together. All right, we're back. And there's really not much to do as far as simplifying. We can just add the inner terms, and there you go. So if you got that answer, good job. All right, one more of these subtraction problems. Try 21, and when you're done, we'll do it together. All right, we're back. And there we go. Combine like terms. And 4x minus 2x is 2x. Negative 8 minus 4 is negative 12. So if you got that answer, good job. All right, so that was simplifying polynomials, writing it in descending order of powers and stating the degree. And we added polynomials and we subtracted polynomials. So you know what's coming next. Time to multiply polynomials. Now I want you to be aware that in this class, we're only going to multiply a polynomial by what's called a monomial. Okay, if a polynomial only has one term, it's called a monomial. Mono means one. If there are 2 terms, for example, you might see something like this. If there are 2 terms, it's called a binomial because bi means 2. And if there are 3 terms, like this polynomial, that's called a trinomial because there are 3 terms. And I don't know if there are names for the. I don't think there are really names for the higher ones. Just monomial, binomial, and trinomial. Mathematicians, as far as I know, don't really use the special names for when you get more than 3 terms. Certainly not in the K-12 curriculum. All right, so what we're going to do here is we're going to use the distributive rule that we used in the previous course. So what we're going to do is we're going to multiply 8x to the 2nd power times 3x to the 4th power. So 8 times 3 is 24, and x to the 2nd power times x to the 4th power. Remember, when you multiply power terms, you just add the powers. So it's just going to be x to the 6th power. So the important thing to understand is we've only multiplied these 2 terms. Okay, don't worry about these terms right now. We just multiplied the first 2 terms. So we added those powers. X to the 2nd times x to the 4th is x to the 6th. And we multiplied 8 times 3 to get 24. So this is very, very simple. Now we're done with that first term, so we're going to move on to the next term. So 8 times negative 3 is negative 24. And x to the 2nd power times x is x to the 3rd power. So all we did there is we multiplied this term times this term. Again, we're done with this term. We're not doing that term anymore. So we just multiplied the blue ones. And so now we're going to multiply this term times 5. So all you do is you just multiply this first term times each one of these terms inside. It's very simple. So 8 times 5 is 40. And x to the second power times, there are no other x's, so it would just be x squared. So that's multiplying a polynomial by a monomial. Again, we're multiplying a polynomial by a monomial. And we're going to multiply a binomial with another binomial in courses later on, or classes later on in this course. So on to number 23. So again, we're going to multiply these two terms. Again, we're multiplying the monomial times this term, then times this term, then times this term, then times this term, and so on and so forth. So the principle is very easy. So negative 2 times negative 2 times positive 2 is negative 4. And z to the third power times z to the fourth power, you just add the powers to get z to the seventh. Again, we just multiplied these two terms. Now we're going to multiply these two terms. So negative 2 times negative 8 is positive 16. And z to the third power times z to the third power is z to the sixth power. So now we're done with these two terms. We multiplied those two. So now we're going to, again, we multiplied this term times this term and this term times this term. So we're done with those first two. And now we're going to multiply by the next term. So negative 2 times 3 is negative 6. And z to the third power times z to the second power is z to the fifth power. So we multiply by the first term, second term, and third term. And now we're going to multiply by the fourth term. Negative 2 times negative 4 is positive 8. And z to the third power times z to the second power, whoops, we already did that one. Z to the third power times z is z to the fourth power. So I'm going to write the fourth power there. And let's see if we can find some more room here. And we have one more term. So I'm going to shrink this whole thing. Sorry about this. I should have given myself a little more room. There we go. And negative 2 times negative 9 is positive 18. And z to the third power times, there are no z's, so it would just be z to the third power. And that is the final answer. So again, we're adding powers on the variables, and we're just multiplying the coefficients. Remember, the term in front of the letters is called a coefficient. So if you'd like to try the next one, you can go ahead and try the next one. So attempt number 24, and when you come back, we'll do it together. All right, we're back. You should have 3y to the 7th, negative 15y to the 6th, negative 3y to the 5th, and 21y to the 4th. And that is the answer. So if you got that answer, good job. Just double checking my work there. Everything looks right. I have to try to make my 4s look like 4s instead of 9s there. I don't want to confuse you. All right, so try number 25, and when you come back, we'll do it together. All right, we're back. So if you got that answer, good job. All right, so go ahead and try number 26, and when you come back, we'll do it together. All right, we're back. And there you go. So if you got that answer, good job. On to number 27. Go ahead and try 27, and when you come back, we'll do it together. All right, we're back. So if you got that answer, good job. And number 28, attempt that problem, and when you come back, we'll do it together. All right, we're back. 5 times, and remember, if there's no coefficient here, that just means it's 1. So 5 times 1 is 5. And x times x is x to the second power. And 5 times 2 is 10. And x times, there's no x, so it would just be x. So if you got that answer, good job. Try 29, and when you come back, we'll do it together. All right, we're back. So if you got that answer, good job. All right, so try number 30, and when you come back, we'll do it together. All right, we're back. So if you got that answer, good job. Try 31, and when you come back, we'll do it together. All right, we're back. So if you got that answer, good job. So it looks like we're going to try one more. Go ahead and attempt 32, and when you come back, we'll do it together. All right, we're back. So if you got that answer, good job. All right, so we're going to do one last thing today. We're going to divide a polynomial with a monomial. So again, when we're multiplying and dividing today, we're only multiplying polynomials and dividing polynomials by monomials. So when you multiplied a monomial by a polynomial, you added the powers, and of course you learned in the last course if you're dividing power terms, then you subtract the powers. But first we go ahead and just divide the numbers. So 10 divided by 2, that would be 5. And we're going to subtract the powers now. So 6 minus 2 is 4. Now we're going to move to this term. 20 divided by 2 is 10. And x to the 5th over x to the 2nd, 5 minus 2 is 3. Negative 16 divided by 2 is negative 8. 4 minus 2 is 2. 4 divided by 2 is 2. X to the 3rd divided by x to the 2nd is x. And there you go. So as you can see, again, we have another example of something that's really not that difficult. But this is extremely important in the beginning algebra curriculum. All right, everything looks correct there, so let's go on to 34. Let's try another one together. So negative 36 divided by negative 9 is positive 4. And y to the 5th over y would be y to the 4th. Again, you're subtracting the powers. And negative 27 divided by negative 9 is positive 3. And y to the fourth over y, again, just subtract the powers, so it'll be y to the third power. And then 45 divided by negative 9 is negative 5. And 3 minus 1 is 2. And negative 81 divided by negative 9 is positive 9. And 2 minus 1 is 1. So instead of writing a 1, we just write nothing there. It'll just be y instead of y to the first power. So let's see here. Let's attempt one more of these problems before you try one on your own. 21 divided by 3 is 7. Z to the 10th over z to the 5th. 10 minus 5 is 5. 9 divided by 3 is 3. And now we have something special happening because the powers are the same. So 5 minus 5, that would just be 0. So that means you don't write any z's at all. They just disappear. So that looks correct. So now it's time for you to try. So go ahead and try 36, and when you come back, we'll do it together. All right, we're back. 25 divided by negative 5 is negative 5. And 60 divided by negative 5. I didn't realize that's not one of our multiplication facts. I'm sorry about that. But that would be 12. 70 divided by 5, that's not one of our multiplication facts either. I'm sorry about that. But that should be 14. And I'm going to move this over a little bit. And then 40 divided by negative 5, that would be negative 8. And that's it. So if that's your answer, good job. On to number 37. Go ahead and attempt number 37, and when you come back, we'll do it together. All right, we're back. And I think that's correct. Let's just double check that. Everything looks right. So if you got that answer, good job. On to number 38. Go ahead and attempt number 38. When you come back, we'll do it together. All right, we're back. So if you got this answer, good job. All right, on to the next problem. Try number 39, and when you come back, we'll do it together. All right, we're back. And there you go. So if you got that answer, good job. I'm sorry about that 6 on the z there. That should be z to the 6th power. All right, try number 40, and when you come back, we'll do it together. All right, we're back. And there you go. So if that's your answer, good job. On to the next problem. And this was kind of strange here because we had negative 6 divided by negative 6. So that would be 1. And then x over x just becomes 1 also. So try number 41. Looks like we have 2 more problems here, and then we're going to be done with the class, and then you just have to do your homework, and then you're going to be done until the next class. So try number 41, and when you come back, we'll do it together. All right, we're back. So if you got that answer, good job. Now in this problem, the powers are not written in descending order, but that's okay. We don't have to change it at this point. That looks correct. Let's go on to 42. Try 42, and when you come back, we'll do it together. All right, we're back. Negative 100 divided by negative 10 is positive 10. And z to the 6th. Negative 5z. And positive 9. So if you got that answer, good job. Just double checking that everything looks right. All right, so very good. If you got through this class, good job. Here's all the work that we did today. If you'd like to take screenshots of these pages to help you with your homework or to study for tests, go ahead and do that now. Now don't go before you get your homework. Here's the homework. Take a screenshot of the first 2 pages here. And then get a screenshot of these pages, the 3rd and 4th page. And you can see you've got the answers down there, so you need to check your answers for every problem. And I want to remind you that, again, the homework is the most important part of this course or any math course. If you don't do the homework, I promise you with every fiber in my body that you're going to learn absolutely nothing in this entire course. And your homework needs to have 4 characteristics. Number 1, it has to be complete. Number 2, it has to be correct. Number 3, it has to be neat. It has to be legible. And number 4, it has to be in order in your binder. If you lose the homework, then obviously it doesn't matter if you did it. And you need to keep a record of your work. If your homework doesn't fit one of those descriptions, then that means that it's just a waste of time. And remember to keep your papers in chronological order. So this page is pretty much the first thing that you're going to do, or maybe the second thing if you kept some notes for the first class. You didn't really have to, but this page is going to be the first part of your binder. Then the next homework assignment, that's going to go right behind this page. And then the next homework assignment is going to go right behind that page. And you're going to keep it in chronological order. If you don't do that, then there's no point in even taking this course. You have to keep all of your papers in order. So that was the class today. You probably noticed that was pretty easy, and it was. This course does start out fairly easy, but it's going to get harder. So I'll look forward to seeing you in the next class.